Okay, so now we're actually going to apply these theorems to find angle measures. So for this first one, I'm going to find all the missing angles, and I'm going to state which theorem I used. So I have 7 missing angles here, but I'm going to use all those theorems that we just talked about to find what each of these are. But first, I can only use those theorems again because these are parallel lines. So that is super important. If these weren't parallel, I couldn't use those theorems. They wouldn't be true. So because these are parallel, they are true. So always check for that. Okay, so when I'm doing this, I kind of just like to start with, okay, which ones are going to be equal to 120? And so I'm just going to go down the list. Okay, what's the corresponding angle to 120? Well, 120 I see is in the top left corner. And so if I go to these 4, the angle that's in the top left corner is going to be 5. So I'm going to go ahead and just write 120 there, just so I remember that one's equal to 120. So I can say that measure of angle 5 is equal to 120 degrees. And the reason for that would be corresponding angles theorem. If you notice, I shorten this just because it is really long. So for corresponding, I just put CORR. And then for angles, I just do the angle sign. And then for theorem, I just write THM. I'm okay with that shortened version because I know writing out corresponding angles theorem is pretty long. Okay, so what else is going to be equal to 120? Well, I see that 120 is on the outside of the 2 lines. So I know it's an exterior angle. So I know by my alternate exterior angles theorem that the alternate exterior angles are congruent. Well, the alternate exterior angle to 120 is going to be 8. So 8 is on the opposite side of that transversal. And so this is going to be by the alternate exterior angles theorem. Okay. Another thing that I learned was vertical angles theorem, or congruence theorem, and that said that vertical angles are congruent. Well, what's the other vertical angle? I see 120 and 4 are vertical angles, so that means the angle 4 is 120. So now that's really all that are going to be 120. And you can kind of see, if you notice, all of these are opened up wide like this, so you kind of see that they are, but don't always just rely on the picture. Okay, so now I want to find the rest of them. So one way I can start off with is angle 2 and 5. I see that those are consecutive interior angles. And we learned in that last video that those are supplementary, so those add 180. So I know that the measure, let's switch colors here, measure of angle 2 plus 120 is equal to 180. So if I subtract 120 from both sides, I get that measure of angle 2 is equal to 60 degrees. And so that was by the consecutive interior angles theorem. Well, and then I know that alternate interior angles are congruent, so that means that measure of angle 7 is equal to 60. And then 7 and 6, those are vertical angles, so angle 6 is equal to 60. I could use vertical angles for angle 3, but another thing that we just didn't get to do for this one is that angle 3 and 120 are a linear pair. I see they form the same line, so that means I could also do 180 minus 120, which is 60 degrees. And so I use linear pair. So for these types of problems, when you just start off with one angle, you just kind of take it one at a time. I like to fill in the picture of everything that I have, and just make sure you're really utilizing all of those theorems to find all of those angles. Okay, go ahead and pause the video. I want you to try that next one on your own. Okay, so these are the answers that you should have gotten. 1, 4, 8, and 5 should have been 105 degrees. So you just do 180 minus 75 to find that. And then measure of angle 2, 7, and 6 should have been 75 degrees. 6 is from alternate interior angles. See that here. 7 is alternate exterior. And then 2 is from vertical angles. Okay, so now let's look at one that's just a little bit different of a picture. So here I want to find angle X, Y, and Z. And I'm going to use my picture for that. So the first one that pops out to me is I see that 60 and Y are vertical angles. And so I know that Y is going to equal to 60 degrees then. And then I see I have two parallel lines here, and I know that from these arrows, and then I have this transversal right here. And so I see that Y and Z are consecutive interior angles. And so that means that Z plus 60 is going to equal to 180. And so then when I subtract 60 from both sides, I get that Z is equal to 120 degrees. And that was the consecutive interior angles. And then now lastly, I see X and 100. They're both on the same side of this transversal now. So this picture really had two transversals. And I see they're on the inside. And so that means these are also consecutive interior angles. So I know that X plus 100 is also equal to 180. And so I subtract 100 from both sides. And so I get that X is equal to 80 degrees. This was the consecutive interior angles theorem. Okay, go ahead and pause the video, and I want you to try that next one. Okay, so these are the answers you should have gotten. So I found that X is 105 degrees, and that's because these two angles are corresponding. Oops, I wrote the wrong reason there. That should have said corresponding. Next I found Z, and so I see that Z and 55 here create a linear pair. They're right next to each other. So to find that, I just need to subtract 180 and 55. And then last, I see that Y and 55 are alternate interior angles. They're both inside the lines and on opposite sides of the transversal. And so that means that Y is 55 degrees. Okay, that's it for this video. You can go ahead and move on to the next one, where we will be continuing finding these angles.